Okay students, now theorem number 10.4. Theorem number 10.4 is the converse of theorem 10.3. What we have proved in theorem 10.3? A line drawn from center of the circle bisect the chord. If the line, or we can say perpendicular drawn from the center of the circle bisect the chord. Now, the converse of theorem is that if a line drawn through the center of circle, if it bisects the chord, then that line is perpendicular to the chord. We have to prove that that line is perpendicular to the chord. So, what is the diagram? Circle is given. In circle, chord is given. Center with circle O, line is drawing to the center of circle. So one line L is there passing through the center of circle, and that line L bisect the chord. So here M is the midpoint of this AB. This is given. So here we have to prove this line is perpendicular to AB. Line is perpendicular to AB. That we have to prove. This is circle with center O. This is given. So now given line drawn through the circle, line drawn through the center of circle to bisect the chord. Here line L is bisector of chord AB. Line L is the bisector of chord AB. That means M is the midpoint of AB, and here we can write AM equal to BM. And to prove, we have to prove that this line, which is bisector of chord passing through the center, that line is perpendicular to AB. So to prove L is perpendicular to AB, or line L, which is passing through the center and which is bisector of AB, is perpendicular to AB. That you have to prove. Done. This is the converse of theorem 10.3. 10.3 में जो प्रूव करना था वो गिवन में है, और वहाँ पर जो यहाँ पर जो गिवन में है वो हमें प्रूव करना था. Done. That is converse. So now proof. We will prove that this L is perpendicular to this AB by using this given data. So here line L passing through the center of circle and bisect the chord AB. So line L drawn through the center, drawn through center O, to bisect chord AB. Line L passing through center O and bisect our chord AB. So here AM equal to BM. We can write AM equal to BM. Say this one is result number 1. Now we will draw radius of this circle OA and OB. So join OA and OB. Join OA and OB. Done. So now we'll consider two triangles OMA and OMB. So in triangle OMA and triangle OMB. So in these two triangles, what you can see here, OA is equal to OB, OM is the common side, and AM equal to BM. So here first OA equal to OB. So here these two line segments are radii of circle, radius of the same circle. So radius of the same circle are of same length. So length of these two line segments are equal. Then line segment OM. Line segment OM is the common side. So that is the equal in length. OM equal to OM. OM equal to OM. It's a common side, and this one AM equal to BM, that is given. AM equal to BM, that is given, and therefore we can write this given two triangles OMA is congruent to triangle OMB by SSS rule, side rules. All three corresponding sides are congruent, therefore given two triangles are congruent triangle. And we know if two triangles are congruent triangles, all six corresponding parts are equal. So these angles are also equal. Which angles? OMA and OMB are equal. So here you can write angle OMA is equal to angle OMB by CPCT. Say this one as a result 2. These two angles are equal angle. These two angles are equal angle. But we have to prove this line L is perpendicular to AB. For that we have to prove measure of these angles are 90 degree. So now here you can see that these two pair of angles are linear pair of angles and both measures are equal. So that will be of 90 degree. So now these two equal angles are linear pair of angles, and linear pair of angles are supplementary angles. Supplementary angle means the sum of measure of these two angles is 180 degree. So we can write angle OMA plus angle OMB. These two angles OMA and OMB, angle OMA and OMB, these two angles are linear pair of angles, and therefore sum of measure of these two angles is 180 degree. Linear pair of angles. So measure of these two angles is, sum of measure of these two angles is 180 degree. And from result 2 we can see that these two angles are equal. So we can replace this angle OMB with angle OMA. So angle OMA plus angle OMA equal to twice of angle OMA equal to 180 degree. So measure of angle OMA equal to 180 by 2, so it's a 90 degree. Measure of angle OMA is 90 degree, and therefore measure of angle OMB is also 90 degree. So these two angles are of 90 degree. So here we can say that this angle is 90 degree. So L is, or we can say OM is perpendicular to AB, and OM is perpendicular to AB. OM is the part of L. So again, next step we can write line L is perpendicular to AB. So line which is passing through the center of circle and bisect the chord is perpendicular to chord. Clear? This we have to prove. Line passing through the center of circle bisect the chord is perpendicular to chord, that we have to prove. Clear, students? Pause the video and do more and more practice of this theorem, and share this video with your friends. Thank you.